member. Here's an overview of what's to come.
Optica will bring together the brightest and best in Los Angeles. Corner New York, Brussels, Glasgow, Sunnyvale, Paris, and Malaga.
Got my shades in the lab about 10:15. White coat cuff like a greaser again. Spinning that prism like a hubcap chrome, turning every photon into fuel I own. It's photonics. Baby, 2026. Riding down a light wave, doing new tricks. From the fiber in the ground to the chip in my hand, we make that sunshine jump on command. Yeah, photonics. Baby, 2026. Tiny little wave got on a thumbnail chip. Makes your eyes look slow and stiff. Lasers in the toolbox, markers on the floor, drawing up a future through a tiny door. It's photonics. They're photonics. Riding that light wave, doing new tricks. From the fiber in the ground to the chip in my hand, we make that sunshine jump on command. Yeah, photonics. Baby, photonics. From a single red dot on a dusty bench to a whole wide world in a data trench. Flip that switch, see the spectrum spin like a jukebox jumping when the coins roll in. Oh yeah! Baby, 2026. Riding that light wave, doing new tricks. From the
It all will happen here at IX Campus Castle of Saint-Germain-en-Laye in Paris. See you then.
New season of 18 Optica online industry meetings in 2026 begins on Tuesday, January 13th. We start at 10 a.m. Eastern, 3 p.m. in UK, Ireland and Portugal, and 4 p.m. in Central Europe. Our topic this time is lighting.
Light was once a switch on the wall. Now it's a system, a signal, a call. Engineered layers, atom by atom, designed to scale, built to connect them.
Materials innovation, new emitters, connectivity, and system integration are all reshaping how lighting is designed, manufactured, and deployed at scale. This Optica online industry meeting brings together companies working at critical pressure points of the lighting value chain, from new light source architectures and OLED manufacturing to quantum dot materials and free space optical communication. The focus is firmly on what is commercially viable now and what still needs to be solved. On January 13th, we'll have leaders from the following companies sharing ideas in the Zoom room. The founder and CEO of Crocus Labs, the CTO of OLED Works, the CEO of OLEDcom, the CEO of Traxon.
I would like to show you a world first. What you see here is a double-sided printed structure on flexible foil with 4,000 via interconnections connecting the front side and the back side, and with 4,000 smallest RGB LEDs, each can be driven individually. So this is in essence a display that's less than a millimeter thick. That's very, very new.
The CEO of Q&A Technology and the product manager of Noctiluca. All-line Optica industry meetings last 90 minutes. And thanks to corporate sponsorship, your attendance is free. So now, let's get started.
This is Optica.
Indeed, this is Optica, and welcome everyone to the Optica online industry meeting on lighting technologies. First of all, you are supposed to say Happy New Year for about 2 weeks. So this is the last time I say to all of you, Happy 2026. I'm pretty sure it's going to be a very successful, a very enjoyable year, and there will be a lot of online and face-to-face meetings of Optica. Always pay attention to the website of Optica. Before we start the meeting, I would like to, first of all, acknowledge and thank the Optica corporate members whose support is the one that gives us a job and the passion to be working for the photonic industry already for so many years. I would like to especially thank our corporate members, Noctiluca and Q&A Technology from Poland, who are really here offering their technology, their material. Today is all about lighting. And Olga Ras, our director of optical instruments, has put together a fantastic agenda. We're going to have Crocus Labs, who is focusing on energy efficiency, Traxon on printed electronics, OLED Works, bringing the organic LEDs to the business, and OLEDcom, who is focusing on Li-Fi, on connections, and all of them need lighting technologies, and we're here, the Optica corporate members, here to offer them our solution. I would like to encourage everyone, if you have not done so already, make sure your company is registered as an Optica corporate member. Go to optica.org/join corporate. You can find there all the membership benefits, but remember, the most important membership benefit of all is to interact with the Optica team, and in this case, with Dr. Olga Ras. Also, I would like to remind that we organize lots of online events. These are the online events of Q1 2026. Today's Optica Lighting. But mark your agenda. In 2 weeks, we have heterogeneous integration on silicon photonics. So any material from organics to plasmonics to quantum dots, how to integrate them in silicon photonics is major end users and major foundries. If you have a material that can be integrated in silicon photonics, 27th of January, be there. And also we have a lot of in-person events. On Monday, we are meeting the executives of our corporate members in San Francisco at the MoMA Museum on 19th of January. If you have not registered yet, send me an email and we'll make sure that you have you are added to the invitation list. And also, I would like to remind everyone that this meeting is live right now in YouTube. So let me say hello to the YouTubers of the world. Hello, YouTubers of the world. You are following in YouTube. If you have any questions, write them in the chat and I will read them in the room. And of course, this is also valid for the people here with me in the Zoom room. Make sure you use the next 90 minutes of your time to the maximum. There is a chat. Use it. in the chat, write what you do, write how lighting is an important business for you, and use it to connect between all of you during the next 90 minutes, because at the end of the day, we are here to find potential partners, suppliers, customers, and of course, investors and talent. And let's start the meeting. Olga, thank you very much for putting this great agenda. Allow me to give the floor to our first speaker today. He's the founder and CEO of Crocus Lab. He's coming all the way from Germany, from Berlin, and Prashant Makarang is going to start telling us about how his business is enabling energy efficient lighting. The floor and the attention of everyone goes to you, Prashant.
Thanks, Jose, and Happy New Year to you too. Share my screen. Good afternoon, good evening, or good morning.
Could you
wherever
swap displays in the top left, top right corner of the screen? You have end show tips, swap displays.
Okay.
Yes.
Yeah.
Perfect. Go ahead.
Good. Okay. Yeah. All right. So yeah, my name is Dr. Prash Makram. I'm the CEO and founder of Crocus Labs. We are a young company. We are still a startup based out of Berlin, Germany. And our mission is to enable the right light at the right time. We started off in vertical farms. As you can see, this on the left side is one of our units that are installed in a vertical farm in Sweden. So maybe once taking a step back, maybe a lot of you already know that for us humans and also plants, we have complex circadian needs, and most of it is determined by the light. So we grew up, we evolved with the sun, the plants evolved with the sun, and the light can have, the light triggers not only our mood, our actions, but also it acts as a precursor to many diseases in humans. And it's the same with plants. You can do a lot of things by tuning the light in plants. So when we started in indoor farming about 5 years ago, there were a lot of big players, but they were all working on either using static blue and red lights or a cold light. And this means that they were either wasting energy or they were stunting the potential of these vertical farms. So they were only able to grow leafy greens. So we introduced dynamic lighting into indoor farming, and our lights, you can tune it not only during the course of the day, but during each stage of the plant growth. And by controlling this, we have shown that this is, for example, what we did with strawberries. We could reduce the energy needs by 22% in strawberry growth, but also not have any yield losses. So this is where we started. So we kind of started with introducing dynamic lighting, 4-channel lighting system into the indoor farms. And then we moved on from there into greenhouses. And greenhouses, we wanted to take it one step further. And instead of a set and forget system, we also wanted to make it completely adaptive, which means we can use sensors. So here, for example, this is a system that we have deployed at the James Hutton Institute in Scotland. So the idea here is that we will have optical sensors, spectral sensors on top of the lights that measures the spectrums that is coming into the greenhouse at a particular time of the day, and then compensate with our lights for the missing spectrums. So by doing this, we don't affect the yield, but at the same time, we can minimize the energy needs. So this is, so we want to go away from completely having a static system into a dynamic system that adapts and we also, something that I forgot to mention here is that we also know exactly what the crop light recipes. We have a huge database of light recipes for each crop. So if you have a strawberry, we know, okay, at this stage of the strawberry plant, what is it that the strawberry needs in terms of light spectrum? And then we use the sensors and light to give it the right spectrum without with minimizing energy needs. But we also noticed that, okay, this is nice, but this is again still an expensive system. You have a lot of LEDs. You have to have multiple LED diodes. You have to have multiple controllers, making it a very expensive unit. So our goal is eventually to minimize the diodes and create specialized spectrum LED chips. In order to do that, we can't rely on traditional phosphor because I guess most people here from the lighting industry, you know that you use the traditional white lights are created by using blue LEDs, and you have a phosphor layer. And when you do the phosphor layer, you have a green gap. It doesn't really mimic the sunlight. With quantum dots, we have been able to mimic the full sunlight. So you can see a sun-like LED, and this is much more efficient, and we have shown it much more efficient than what's the state of the art in the industry. But also we can create specialized spectrums, and this is where we are moving away from plants, also going into human circadian rhythms. For example, you can create 20 to the 100 Kelvin lighting without any blue in it. Of course, this is, and then for agriculture, we can tune in and create specialized strawberry spectrum, for example. So this is kind of our goal. We are still at now it's a TRL 5-6 with the LED chip. So we are trying both on-chip conversion with quantum dots, but also remote conversions with QDs. We don't synthesize QDs. We work with partners. One of the advantages of being a vertically integrated system, vertically integrated company where we manage the entire stack from LED, the quantum dot coating all the way to the system, means we can optimize the system for photon efficiency, but also we are not restricted by shape and size. So we can go from greenhouse lighting to a wearable device. This is a project that we have recently gone into. So from agriculture, we are also going into medical devices, and we just completed a pilot for the largest medical device company in circadian rhythm management. So, and beyond horticulture, of course, we see ourselves going into health and wellness. We have been approached by a couple of tier one automotive for both interior and backlighting, but these are very low. These are innovation projects in the automotive, so we are far away from anything that is manufacturable. But at the moment, our major focus are in horticulture and health and wellness. With that, I would like to end my talk, and thank you all for being here and listening to our presentation. And if you have any questions, feel free to reach out to me by email or through the chat. Thank you.
Thank you, Prashant. That was interesting. I love strawberries. So what is that they need?
Well, yeah, I think they need a lot of things, but light is, of course, the most important thing, right? But what is interesting is that we can tune the taste of strawberries also. So we've been working with a Japanese strawberry seed maker called Miyoshi, and they make this tastiest strawberries, and you can actually use light to make sure that you get those tastes in your strawberry, and not that strawberries don't taste bad. So I should say.
What is their favorite wavelength?
I think it's hard. And also as I said, that's why we have this huge database, right? Because each stage requires different things. For example, if you want to trigger flowering, you need in far red, more of the far red. And if you're at the vegetative stage, you need more blue and red. So you need, the idea is to manage the red to blue ratio and red to far red ratio. So how you manage it at each stage helps you determine how much energy efficiency you have and how much taste and other properties you can get out of the strawberries.
Thank you. We have a question in the chat from Viadhav Jeta. Viadhav, can you unmute yourself and ask your question?
Yeah, thank you so much. First of all, wish you a happy new year to all of you. So my
Thank you.
question, yeah. So my question to the Prashant, so is it limited to only for the the closed farming, or can we use this lighting system for the open farming also?
Well, we're going into greenhouses, right? So it's kind of semi open, I would say, or semi closed, however you call it. At the end, in outdoor farming, it doesn't make sense so much. You have sunlight for free, so why bother to have lights? The only place where open farming helps is if you use UV, which we don't do so much, is for disinfection or crop pest management, etc.
Mhm.
Okay, thank you so much. And so suppose
And also
we
infrared, the latest research, actually, maybe one more thing, infrared for frost management. If you're at night, you can use infrared and you can try to manage frost in
yeah,
the
yeah. So in India, actually, we use normally pesticides to control the crop and uh, yeah, the fungicides. Okay, so how it's effective from that perspective?
Mm. I'm not an expert in UV, right? So there's UV disinfection, but we can have to take this call, or I can give you more information afterwards, but I don't have it right now.
You have to
Thank you so
introduce
much.
maybe yourself, why you're so specifically interested in this. What are you doing?
Yeah, actually, I'm working with the automotive systems in India. So I just ask because in India, actually, they are referring to the open farm systems. And I just want to know the cost comparatively. If it is the better than pesticides, then we can use the EV lamps and the lighting system in the agricultural. Then it will the cost effective, and it will be the health beneficial.
Definitely not cost effective, I would say. It's because there is
Yeah,
some, I know the Indian market, there were a lot of, we were trying to get UV purifications for water, right? And it's difficult. UV LEDs are expensive, inefficient. So you need to have a lot of them. And then you go to the pesticide manufacturers and they give you, and especially in India where pesticides, there's no regulations on what you can put, what kind of poison you can put into the pesticides. You can get away with it. So you can really go with cheap pesticides. It's important now. The lighting will not be
yeah.
cost effective at all. It will not make any economic
Okay,
sense.
okay. Thank you so
We have
much.
also a couple of the further questions from the speakers. Benjamin, tell us what's on your mind.
I remember that Philips Signify had a huge business in horticulture lighting, if I remember well. I was working 10 years ago or 15 years ago about that. I don't know where we are now. Is Signify still a competitor to you, to your company? And if yes,
Signify is still a
what is
competitor.
your main differentiators?
The biggest differentiation is the fact that we have this whole dynamic lighting system, right, and energy optimization, and the big database that we have. Signify is working only on static lighting, right? They've been trying to come up with the dynamic lighting in the last couple of years, I know, but they don't have one in the market.
Okay. And
Congratulations.
another question from Michael. OLED works?
You mentioned light for medical applications. What kinds of wavelengths of light and what kind of applications are you considering?
We are considering mostly on sleep, managing insomnia. So the wavelengths that you really need are around cyan wavelength for 80 nanometers. So you need to have a lot of sky. So the idea is that you need to be exposed to a lot of light early in the day, especially for 80 nanometers around that range. And then towards the evenings and late evenings, as you go wrapped down, so ready to sleep, you need to have as little blue as possible, but then you need to have more infrared, red and infrared that time as the sun, because then you're kind of emulating the sunset and slowly going towards your sleep or resetting your circadian rhythm so you can sleep.
Thank you, Prashant. And I think maybe one question from my side, because when we speak about agriculture, also medical applications, efficiency is also very important. How do you compare, or is it a critical parameter that you always have to carefully watch?
Yeah, of course, right? Because power management in wearable devices is a critical topic, and you need to make sure that you have the most energy efficient system, so you don't need to charge your device every day, and you can run your device over for a week before, especially in clinical settings. We don't want in clinical settings, also in sleep, right? We are tracking light exposure of people during the day, and we also want to make sure and understand how they are sleeping, right? Then you don't want to have multiple wearable devices. You want to have one wearable device that you can use it for a week. Then we know, okay, this person's been exposed to this particular wavelength over the day, and then we kind of give them the right wavelength And at the same time, we also understand if it's actually having a benefit.
Jose, back
Olga,
to
we
you.
have a question from YouTube. I would like to bring the floor. Well, I will read the question myself. The question is from Jonathan Marks, and he's actually asking the same question as Michael Boroson from OLEDworks. What wavelength is the right one for for the diseases section? And I am going to Prashant, I'm gonna shape it a little bit because you already said you're trying to avoid insomnia. You are going for blue enriched light during daytime and low blue in the evening. Are there any challenges when it comes to the light sources or the materials that maybe corporate members can help you with in this blue enriched to low blue transition?
Yeah, I think the biggest challenge now is we don't have 480 nanometer LEDs, right? So we still don't have the cyan and green. And this is why one of the reasons why we are also working on with quantum dots to try to get this this wavelength. The other thing is, of course, the fact that all LEDs, even your warmest LED has a huge blue component in it. So we need to have a way to kind of turn off that blue component in our warm LEDs.
This is a call for every Optica corporate member right now. You have 480 nanometer LEDs. We are calling you. Back to you, Olga.
Well, then maybe next speaker will be able to comment on this one. And it's my pleasure to invite Ashok from Traxon to the floor.
Thanks, Olga. I'll quickly share my screen. Hopefully, things go smoothly.
So far, so good.
In the meantime, Happy New Year, everyone. My throat is a bit off. Please bear with me. Yeah, so my name is Ashok Sridhar. I'm one of the founders and the CEO of Traxon. My talk for the next 10 minutes will be on LED foil technology for next-gen lighting systems. I might not be able to specifically answer your point, Olga, but I'll try to kind of beat around the bush to give enough information, I think, in the next few slides. First of all, a few words about Traxon. We are based in Eindhoven, which is emerging to be the high-tech capital of Europe these days, with companies like ASML, Philips, NXP, all headquartered here, and of course Traxon. We are a spin-off from TNO Holst Center. Holst Center is actually a collaboration between TNO, which is similar to the German Fraunhofer, and IMEC, which is the Belgian Microelectronics Center. So this center has been developing building blocks for printed electronics for the past 20 years, and all the founders of Traxon, we come from that background, taking the lab scale technologies into manufacturing scale. So we are a foundry, a fully integrated foundry for printed electronics. We co-design with the customers, co-develop the product, prototype, and then upscale in terms of mass manufacturing, all under one roof. We specialize in so-called roll-to-roll processes, so roll-to-roll printing of circuitry, and also assembly of components like LEDs on the printed circuitry, as well as post-processing operations like lamination, laser cutting, programming, and testing. So basically, the full electronics foil is what we create at Traxon. And all these are thanks to a lot of background R&D by our parent company, more than 500 plus person years, and we inherit them to move fast into manufacturing scale. On top of this, we are also building our own unique production equipment. There are gaps in the markets that cannot fulfill what we would like to achieve in terms of products. So we also design and produce our own equipment going forward. We are not just a lighting-oriented company. We also do IoT devices, smart clothing, health patches, and so on, a sample set of which you see at the bottom of this slide. That's briefly about Traxon. Going to the core topic of this presentation, we think the lighting needs a rethink. What is our perspective on that? If you look at the current lighting systems, they are limited in terms of form factor freedom and application possibilities. Also, the form, which is the light, and the function, rather the function is the light, and the form, they are discrete without any fusion. So the user experience takes a backseat. Also, the multifunctionality is lacking. For example, the lighting and sensing fusion is very limited. Also, as the previous speaker, Dr. Prashant, highlighted, right, the dynamic lighting and all these, how sensors can interact with the light and the other way around, that is very limited as of now. And for us, the fourth point is extremely important, having come from this TNO background. The current devices, the luminaires, the PCBs, and so on, they are low on sustainability. typically created using the chemical etching technologies in a subtractive manner and also high on bulkiness. So a lot of materials wasted and removed and not really recycled at the end of life. And of course, the last point these days, geopolitics takes one of the top 2, 3, seats in any discussion. There is a strong supply chain dependency on East Asia, driven by volumes and economies of scales and established the manufacturing base there. So all this mean there is a need for rethinking of lighting systems. And we think printed electronics is a potential solution. We can actually, as the name says, additively print the circuitry required for lighting or displays or whatever on flexible foils in a roll in a fully additive manner. So if you look at the example, this is not lighting yet. You see a very flexible foil on which multi-layered circuitry is directly printed. No etching, you only print what you need. And on top of that, we can assemble components like chips, LEDs, batteries, and whatnot. And this kind of fuses the form and function, thereby opening up many application possibilities. And the middle part, which is also actually kind of explained also at the bottom part of the slide, the technology is highly sustainable, up to 5 times lower CO2 emission, 12 times lower materials consumption compared to the traditional electronics PCB manufacturing, less than up to 10 times lower waste, up to 5 times lower energy consumption in terms of manufacturing, and we do not use any water at all in the facility. So no fresh water, no wastewater. And also, because this can be done in a roll-to-roll process, 2 operators, 2 qualified technicians can operate a production line that can produce square meters of circuitry each minute. That's what we're talking about. So high level of automation is possible. That offers a lot of possibilities for the lighting applications, which I'm going to show on in the coming slides. Before that, what are LED foils I'm talking about? As the name says, well, there are foils on which we print the circuitry and then we assemble the LEDs on the foil. That's in a simple sense, LED foil. I'm going to show a series of videos. The first one showing a top view of our roll-to-roll screen printer. The technology it's been there for centuries, but the way we do it, the process and the accuracy is extremely high. So what you see is the silver paste, or copper could be as well, is printed onto a flexible foil, and that's transferred basically. And then this circuitry, that's a basis circuitry for the LED foil, that then goes into a curing oven in line, as you can see here, where the printed ink or the paste is cured almost instantaneously. So as it comes out on the other side, it's fully conductive. So that is the basis for the LED foil. And there are many flavors to it, which I'll show on the next videos. Here you see a very wide format, 0.6 meters LED foil on a non-transparent PET. Very simple circuitry for lighting applications, just lines, but it can be printed again in multiple meters, linear meters per minute. And the last example here is printing of a semi-transparent circuitry on a transparent foil for glass integrated lighting and display applications. So there are multiple possibilities enabled by this additive printing of circuitry using our technology. And then all of these, of course, are done under strict ISO standards, as you can see on the top of the slide. Once the printing is done, then we go to the assembly part, where, this is slowed down here. The solder paste or conductive glue is dispensed or printed with stencil printing on the circuitry. Then, as you see on the right-hand side, very high-speed pick-and-place machines can pick the LEDs from the reels and place it on the printed circuitry, and then they are reflowed to create the lighting LED foils. So that's kind of the process flow and how we manufacture LED foils. Of course, there's a lot of knowledge behind it and design rules behind it. We don't have the time today, but if you have any interest, we can discuss offline. Now, with this approach, roll-to-roll printing on very thin, flexible foils opened up multiple application possibilities. I've shown a selection of them right here. The top left one, you see, it's a kind of a small area device, green LEDs with a very high density mini LEDs assembled on a semi-transparent circuitry. These LEDs, each of them are only 150 micrometers by 200 micrometers in size, And the full area of this device, there are 26,000 of these mini LEDs, and these can be integrated in glass or even pasted onto the glass. Such thinness is possible. On the other hand, the one right next to it is really big. My colleague Sana is holding this foil that's about 2 meters long, hanging from the ceiling, 0.5 meters wide, and there are 800 high brightness warm white LEDs. Again, the whole thing is probably a kilo heavy. So there is no installation needed. This can be just pasted onto the wall, for example, of your living room, and this can act as the ambient light for the room. And there are many other possibilities, RGB. Think of Philips or Signify hue lighting, but only very large format that can be controlled with an app, with these individual RGB LEDs being controlled. These are some of the examples. On the bottom side, you see bottom left is a blue LED for example, therapeutic applications for skincare and so on. The blue wavelength also discussed in the previous talk as well. And there are a couple of others I'll skip for now. The last one, bottom right, this is not what we did, but we are part of this consortium called 3DOP, where Signify is also a partner. Signify and our parent company, Whole Center, realized this 3D kind of kirigami design for the LED. And then there is this 3D printed luminaire to have a highly customized lighting device where, again, the form and function merge and fuse and go hand in hand. So these are some of the examples of what the LED foil technologies allow. And what's next? Well, we are actually working on I mentioned about the lighting sensor fusion. We are working on IoT-enabled connected lighting systems. We have a few projects running. And there could be, again, multiple possibilities. There is this LED foil, of course. You can think of integrating a sensor, for example, a photodiode, already in the same circuitry on the same foil. And depending on the local, let's say, ambient light, I mean, for instance, in the room also that the external light comes in, then the foil can adjust itself locally to be brighter or less bright or change colors or whatever. Or it could have a radio chip directly on this foil that can be used to control with an app like Philips or Signify hue lighting. The last example, it's the other way around. We collaborate with a Swedish company called Epishine. They have their own flexible PV technology for indoor light harvesting. So this can be, for instance, a retrofit. This solar cell can harvest the light from Traxon's LED foil, and the sensor can, for example, measure the ambient temperature or pressure, or humidity, and communicate to the occupants of the room, for instance. So lighting can be controlled, or lighting can be used to drive other sensor functionalities. These are the possibilities the printed electronics and LED foils offer for the future IoT connected devices. With that, I'd like to end my talk. If there are any questions, I'd be happy to answer them. Thank you so much.
Thank you very much, Ashok. Ashok, which colors are currently available? Because we're now in search for 480. So it doesn't matter for you, because basically for you it's the end step, the assembly.
Exactly. I was expecting the question. We actually have no control over the LEDs. We just source them. And there are indeed whatever is available in the market, depending on the customer needs. For instance, we have an interested customer in light therapy. In the past, we had someone asking for near infrared for so-called smart headbands to interact with the brain, to activate the brain, so to speak. So we are just users of the LEDs. What we focus on is, can we take those LEDs available in the market and convert them into applications that push the boundaries of what is possible, thereby merging the form and function? That's what we focus on.
Do you see more interest in making this LED smaller and smaller? And if yes, then what are the limitations? Because now it's 150 by 200.
There are smaller ones. Actually, here I was a little bit, how to say, it's kind of a dual functionality. What we intend to do with this example here on the slide is actually a display. So yes, it's monochrome. So the smaller size is being driven by the display applications. For instance, automotive companies are asking for, you have these cars are becoming gadgets. You have huge glass surfaces in cars, the front glass, the windshield, back windshield, and so on. There is an interest towards having clusters of displays sandwiched within the glass panels. So it should be super thin, because a typical glass window is a multi-layered glass laminate. They're pressed together in an autoclave process. They would like to have a foil, a printed foil with very, very, very small and thin LEDs that can also be pressed together to create this laminate. And these form local clusters, for example, as warning icons or even entertainment for the passengers and so on and so forth. So it's actually the display application that drives the miniaturization of the LEDs. We are with our technology, I must be honest, we are confined to the so-called mini LEDs at the lower end. We cannot go to the true micro LEDs because anything that is, let's say, 50 by 50 micrometer size, we cannot print such complex and fine circuitry in a large size. So what I show here, this 150 by 200 microns, that's kind of the limit where we are at with our backplane technology.
Thank you so much for the comment. And there's a question from Michael from OLED Works. Michael, what's on your mind?
Yes, I was wondering, for these foils, have you looked at their temperature and humidity reliability? For example, have you tested at like 85 degrees C, 85% humidity? And if you have, how many hours before you start seeing damage to the foil in some way?
Yeah, that's a very important question because what you just mentioned is little bit the job of our parent company, Whole Center TNO. They do all kinds of reliability testing and lifetime testing and so on and so forth. What we focus on is the application, and it's our customers that typically test those things. Having said that, we do our own testing as well to a limited extent. What you see here on the top, from the left second picture, maybe you see my mouse pointer. That LED lighting foil, the very long one, we do in-house testing. Now it's not accelerated. 15 months of switching it on each day from 9 to 6, for example, and then see if there is any degradation in the light emission and so on. There is none. And there is also, for a different application for displays, we also do continuous on and off for tens of thousands of cycles. So these are some of the we cherry pick and do some testing, but we do not do systematic testing. That's either the task of the customer that we supply to or the R&D centers like a parent company.
Thank you, Ashok. Prashant, question maybe from, I will ask for your comment, because you said that this is a system integrator, you look at this as entire system. How do you see the possibilities of such foil for your vertical labs, for the vertical greenhouses?
I think it's interesting, but I need to actually something I need to talk to Ashok maybe later on, and maybe Ashok can also already answer, because these are for displays, right? What we are for the vertical farms, we are using mid to high power LEDs, right? And then the question is, can we build a 100-watt lighting system with these foils? And if so, how would you manage the thermal mass?
Yeah. No, that's a very good one. Again, this is not just for displays, also for lighting. So, for instance, there are a couple of examples that are really for indoor interior lighting. But indeed, to be very honest, one of the very first applications I looked into was vertical farming, and looking at the requirements and having learned about the requirements, the power indeed is higher than what our foils can handle. Because end of the day, we do our processing on low thermal budget PET foils. Of course, we can also use polyimide, for example, then the price just shoots up quite significantly. The whole, let's say, the USP of the technology is, can we use low cost PET that can be fully recycled? That's what we focus on. But what you need indeed is high brightness, high power, that's going to create a lot of heat. And this is something I do not think at this stage we can handle reliably. That's the honest answer. At least theoretically, based on what we have analyzed, that's a bit too far for this technology.
I think along the same lines, there's a question on auditorium from Dr. Jay Shankar Kumar. Jay, could you please unmute yourself and ask your question? Jay? Well, if maybe
Yes,
not, then I will, yes, come in.
my question is related to lead file. Is working lead file, how range of voltage on that lead files work?
I'm not sure I understood your question. Volga, did you get
Good
the
that
question?
it was posted in the chat. So what is the range of the voltage for this working LED foil?
Well, I mean, it completely depends. Each device have their own range, right? So, for instance, the LED foil right there, this long foil, if I remember correctly, the current is a few amps, and the voltage we used to run it to is about 50 volts, if I'm not wrong. So, but again, for the smaller foils, it's different. So, each one is depending on the application. So, I can answer your question offline if you have a specific case in mind, Dr. Jai.
Yes, sir. Thank you, sir.
Sure.
Thank you, Ashok. I was curious because now you do pick and place. Do you think it's also this technology compatible with injection printing that you can inject print something on top?
Inkjet printing, coincidentally, that was my PhD that 15 years ago. Inkjet printing of structures is definitely possible, but again, now going back to the previous question from Dr. J, what is needed is, I mean, if you look at higher brightness, larger areas, and so on, you need certain thickness of the conductors to be able to conduct the right and also have the right brightness and so on and so forth. Inkjet printing, if you want to realize, for instance, a 15 micrometer thick deposit after drying, there will be multiple passes required to get there. And probably after each pass, there needs to be a semi-curing or a full curing step. That is not economically viable or feasible. But also, the more the layers you add, and then they are cured multiple times, you also get certain porosity, and when you flex, there is going to be some cracks. So our preference is to stick to, for example, screen printing, where you get to the thickness already in one pass or two pass, and it can stay onto the substrate when you flex, when you stretch, and so on and so forth. So inkjet is possible, but it's going to be certainly expensive and also probably unreliable for the things that we're looking at.
I was asking because I'm curious if you can print the quantum dots on top of the LEDs to get all the possible colors that Prashan wants to reach.
Yeah, probably. Again, all admission, I'm not an expert there on the quantum dots. This question has also popped by before, has come by. I'd be most happy to talk. Printing of something on top of what we have done, whether it's graphics, whether it could be quantum dots, or even printing of sensing functionalities, is all possible with this technology. We just have to be mindful of the topography and the size and the throughput and so on and so forth.
Thank you so much, Ashok. And of course, I asked this question to slowly ask the expertise from the really quantum dot professionals. And I would like to invite to the floor Q&A Technologies. Andrei, the floor and attention of everyone is yours.
Yes, please let me show my presentation. All right. I hope you can see it already.
Yes.
So my
clear.
name is Andrzej Nowek. I am representing here company Q&A Technology. So we are from Europe. We are based in Poland. We are producer of inorganic nanomaterials, and we are developing them, and they are basically meant for advanced technologies. Our strengths are in synthesis of nanomaterials, their modifications, formulations of inks, and upscaling of processes, because we are taking them from let's say level of R&D to industrial fabrication. From the point of view of products, we are focusing on basically QDs, quantum dots that are emitting in blue light spectrum. We have them in let's say, forms, for types of products. We can create solutions or basically suspensions of them in different monomers, different types of solvents. There are also inks, UV curable inks that are patentable, and we are also creating resins and plastics. So our product at this point is already of high quality, and we can create them in industrial grade in bigger, let's say, quantities. We can also provide material that is patternable, and those are basically confirmed with different techniques. And when it is in form of UV curable material, it can be delivered with high resolution. In terms of this, what we are we can provide, we can divide our materials for two types of applications. So first would be with photoluminescent material, and the second one is for electroluminescence. So what is worth to mention is that our materials on photoluminescent side, they are basically receiving, or they can be excited by light with broadband in UV spectrum from 360 to 405 nanometers. And through this, we can receive very uniform, very good, narrow, specific light in blue spectrum. The second thing to mention is that basically one can create, with the same kind of UV excitation source, can create different colors, different basically objects that will deliver light with specific properties, but then they can be switched to next one with the same excitation source. Also, it is possible to have a layer of uniform dispersed light, also excited from UV source, and then therefore it is usable, for example, for creation of foils on layers of material where basically uniform light is expected, for example, for different industrial or medical devices applications. Basically, one with a specific, let's say, UV light source can create well-performing, good quality, specific frequency light source in blue spectrum. So for applications within electroluminescence, basically major applications are within display, and here we have examples of such applications for automotive industry. Everything one can think these days regarding, let's say, HUD applications. This what is necessary for assistance for driver can be created this way. Also, light emitting components for interior, but also for exterior. There are many assistive requirements from the market these days, and those are just examples. They can be created with use of our technology. Of course, we are creating material, and then it can be used by manufacturers to create devices that are, requested by the market these days. So at this point, I would like to finish this presentation. If there are any questions, please reach out to us, and we will try to address them all and create together good product for the market.
Yes, Andrei, I am so happy to see this presentation. I really would like to congratulate you. You went from grams production to kilograms production in Poland. This is fantastic, and you are enabling so many markets. I would like to start by asking you, what are the main challenges of going from grams to kilograms when it comes to control the emission peak, the PLQY, the surface chemistry? What are the main challenges here?
Oh, I think everything you mentioned there is important, every part. So we are already, long way to producing those materials. So from the product that was basically, which is still wet bench product, we've came to industrial grade fabrication. And we have proprietary techniques for example, clean our materials. So that's the one that's must to have in this type of industry. So we can also, creating nanomaterials. We can help with those with other, let's say, types of materials. It works
Andre,
this way.
we just saw from Prashant from Crocus
Mhm.
Labs that he's looking for 80 nanometers. You produce quantum dots from 425
Yeah,
to
well, we can
465. Can you
maybe
push
have.
it to 480?
Yeah, it's on the verge, let's say. But yeah, maybe we can have a discussion, and maybe
We
there are
can have
some
the discussion.
possibilities.
Prashant, are you in the room with us? Can you challenge Andre?
Yes, of course, Andre. I would very much like to have 480 nanometers all the way to 500 nanometers or even 520.
Oh well.
Is there
Yes.
any
Well.
particular request, Prashant, that you may have on the process? Are you looking for later having these quantum dots imprinted or inject printed or with any kind of lithography process?
So yeah, it'll be similar to what he's showing here, right? We will
Yeah.
use a UV or a blue LED to excite them. I'm not sure if we will put them directly on the LEDs. Maybe it's a remote.
Yes, of course. You can basically, the idea behind photoluminescence material is that you can basically create a layer which can be, for example, like work as a filter for verification even, and you can have very cheap solid state UV light emitting light source, and then basically receive, because those materials we are creating, they are very good in conversion. So we have to check what is possible.
Maybe
you.
a different question, right? Because now you're exciting here at up to, because yeah, you have 395 nanometers, but you're also exciting from 360 nanometers all the way to 405 nanometers. If you change the excitation wavelength, can you also switch the output wavelength?
No, but basically, this is dependent of the material. Okay, the specific frequency. We can control frequency of light. Resolution will be by 1 nanometer, basically in the spectrum. We can do it, but then like they would absorb basically everything which is beneath, I mean, from UV spectrum. So this doesn't affect the frequency of the light emitted by the QD, which is excited from external source. So the energy is absorbed, and then basically it creates specific frequency, specific right to the type of the QD. So this way you can control the light, right? With right quantum dot, you can create specific wavelength from something which is below.
Andre, you have to follow up with Prashant. We have another
Yeah.
question for you. It's coming from Michael from OLED Works. This is the Chromium question. Michael, what's on your mind?
Yeah, well, I have two questions. One is, are your quantum dots chromium free? And second of all, similar question I asked before, have you done any testing at elevated temperatures and humidities like 85 degrees C, 85% humidity? And if so, how many hours before the quantum dots are damaged?
So maybe second question first. We have material which is like polymer, and those quantum dots are dispersed in basically thermoplastic polymer. So because of this, they have to survive the process, right? And those are meant, for example, for creation of injecting molding parts, components, for example, applications where you want to have some type of security in place. So it is possible. We've done it already with higher temperatures. It is a little bit different approach when there is necessity for high temperatures, but then if you have a customer who needs such application for high temperature applications, we can probably also have a conversation and see what is possible in the spectrum. And your first question was, can you repeat?
Michael, before we go to your first question about the chromium topic, why are you asking this question? Are you wondering if Q&A is ROS compliant?
I mean, so we're focused on automotive applications, and we're required to do lots of testing at elevated temperatures and humidities for the lifetime of the car. So trying to understand how broadly these different technologies, are possible to eventually meet those kinds of applications, and whether we would, consider using them in products for automotive applications.
Yeah, well, we can also pattern our materials with different techniques. We can create, for example, applications in terms of like meta optics also. They are suitable for it. They are patternable by nano-imprinted lithography with high throughput, with let's say good resolution for applications in light emitting applications, let's say, in general. There are a lot of possibilities actually. And also we have resist, so that's another thing. Well, if you are interested in such possibilities within automotive, it is good to have conversation later on. Please contact us and we can find the solution.
Sorry, maybe just Michael, you were referring to cadmium, right? Not chromium. Just
I'm sorry, cadmium.
Yeah, so typical indium phosphate. There are quite a few indium phosphate QDs out there, and they are ROHS compliant. But cadmium, depends.
So we don't have cadmium in our products. We are from Europe, and we don't do those things.
Thank you very much, Andre. And well, since we have started the conversation about the automotive and Michael expressed his specific interest, Michael, why wouldn't you tell us a little bit more about your solutions and where you are looking when you're speaking about lighting? So welcome to the floor, Michael Bornson, OLEDworks.
All right, let me
we already hear you.
Can you hear me? Okay, so I'm sharing my screen. Shoot, just looking at it.
Are the solutions on the ceiling from OLEDworks, the lighting?
Sorry, right, I'm not sharing my screen yet.
I really am enjoying the meeting so far. It's been great.
Sorry. Shoot, can you see my screen? You can't see my screen.
Not yet. But we are
yet.
so excited.
Sorry. Oh, sure.
Now it works.
Okay.
It's coming up. Yes, here it is. But the question, the ceiling, the lighting on the ceiling of your office, is it coming from OLEDworks?
So yes, the lighting on my ceiling is actually an OLED light source. Actually, it's OLED lighting panels going down and LEDs bouncing off the ceiling it's not in your direct field of view. So it's actually a hybrid solution of OLED and LED. And beautiful lighting, full spectrum, very high CRI. So beautiful lighting. But today I'm going to talk about our lighting for automotive and specialty markets, which includes some white also. So anyway, thank you again for the opportunity. to introduce you to the latest developments in OLED lighting and how those developments are really revolutionizing lighting for the automotive market in particular and other specialty markets. OLED light sources are unique in that they are the world's first true area light source, rather than the point sources that you get from incandescent or halogen or fluorescent or LED technologies. OLEDs generate uniform light with sharp, high contrast edges over areas of any size, from microns to millimeters to centimeters to tens of centimeters, and any shape segments you want, from arrays of squares or rectangles, triangles, organic shapes, images, logos, really anything one can imagine. The light can be generated over that pattern. And this means that we can start using light in ways that were never before possible. And in particular, in automotive, we're seeing it used both as illumination, but also as communication to create a real high visibility types of lighting, especially for exterior. When we when we talk about OLED lighting, it really allows the lighting designer to both design both the size and shape of the light source and how that size and shape is subdivided into individually brightness controlled segments. This is not possible with LEDs or any other light source. If you think of it as an artist can choose their canvas and the size and the shape of the canvas, and they're also free then to fill that canvas in any way that the designer chooses. Our latest OLED 2.0 technology has increased the number of individually controlled segments from less than 10 per panel to up to 128 per panel. And our future technology levels, as demonstrated in the video here, will increase that number to hundreds, thousands, and even tens of thousands of segments per panel. So you can start thinking of this as, a light that's also a display, or a display that's also a light, because we also can create extremely high brightness from these OLED lighting panels. The increased segmentation enables brand differentiation, user-selected lighting signatures, and then sharp images for communications from the car to its surroundings. So instead of just seeing the light level change when the person in front of you is braking, you can actually also get information specifically that the car is going to brake soon, but is not actually braking yet. So this technology is actually already on the road in several vehicles. And the combination of illumination with image-based communication is increasing automotive safety and saving lives. I keep asking about testing, and that's because our Atala digital OLED lighting panels are robust and automotive certified, and they've had to pass very stringent reliability testing demanded by the world's leading OEMs and Tier 1 suppliers. Shown here is just a short list of some of the reliability testing that our Atala digital lighting panels have to pass to assure the 15-year lifetime requirement for automotive manufacturers. For example, you see here tests that range from on-state testing at low and high temperature, from minus 40 degrees C to 85 degrees C for thousands or even tens of thousands of hours, to storage testing for thousands of hours at 85 degrees C and 85% humidity, or even up to 105 degrees C. Our testing also has to include things like thermal and mechanical shock, mechanical vibration, exposure to corrosive gases. All of these have to be passed in order to be selected for actual automotive applications. With hundreds of thousands of OLED lighting panels on the road today, not a single OLED digital panel has been returned due to an OLED manufacturing defect. 10 years ago, very few people would have believed that OLED lighting panels could be that reliable. And the truth is that early OLED lighting panels made by some other very well-known companies were not reliable. OLED Works, however, was focused on developing these high reliability OLED automotive lighting panels So we started that development 8 years ago, and we introduced our first flat panels 5 years ago. Our mission has been to make the world's highest performing and most reliable OLED lighting panels, and we've done that. Oh, what's next? Because car exteriors are not flat, the next major innovation in automotive OLED lighting technology is the Atala Wave product. These are the first commercially available automotive qualified bendable OLED lighting panels that match the reliability and robustness of our Atala digital panels. They're made on 0.1 millimeter glass because glass is impermeable to water and water damages OLEDs. And they're capable of a bend radii as small as 200 millimeters. The Atala Wave panels match the elegant curvature of the car exteriors while also improving visibility and safety by helping to define and visualize the car's full width by wrapping around the corners of the car. This is very important for safety, for people to understand exactly where the edge of the cars are for avoiding collisions. Reliability testing of the Atala Wave panels includes all the same tests that I just showed you for the flat Atala digital panels, plus the Atala Wave panels have to be tested in both flat and bend states to be sure that they have the same road reliability as our Atala digital panels. The panel shown in this slide is actually the first prototype panel developed using an organic panel shape and 14 individually controlled and brightness controlled segments with a beautiful exterior, elegant curved surface. This slide shows just some of the Audi vehicles currently on the road that are using the Atala Digital 1.0 and Digital 2.0 technologies. And the difference between those is really related to the number of segments individually controlled per panel. Most of these cars, the OLED rear combination light is actually an optional upgrade that a high fraction of the Audi customers have chosen to pay extra to have. One thing I want to point out, though, is the A8 OLED rear combination light is standard equipment, which means that Audi is absolutely confident that OLED RCLs are 100% reliable, as there's no LED RCL alternative for that car. And they wouldn't be able to sell a single A8 if they couldn't use the OLED RCLs in that vehicle. The Atala Digital 2.0 technology was first introduced in the Q6 e-tron, and now on the road there are 4 more additional Audi cars. All of these cars use the Atala Digital 2.0 panels, but with only up to 64 segments per panel. Coming to the road soon will be the Atala Wave 2.0 and some Atala Digital 2.0 panels with now 128 individually controlled segments per panel, moving us again closer and closer to display-like lights. OLEDWorks is the world leader in automotive OLED lighting. We work closely with OEM designers and engineers to create custom lighting panels for each individual car model. For example, we were one of only 10 companies across all technologies to be invited to participate in the Hyundai Open Innovation Lounge. Working together, we developed a unique branding and rear lighting concepts for the Genesis GB80. We then created a lighting prototype using modular panels to illustrate the lighting quality and capabilities of the Atala Digital and Atala Wave panels. Because OLED lighting is new to most lighting designers and engineers, OLEDWorks understands the need for and is committed to working openly and collaboratively with OEMs and Tier 1s to create unique products not possible really with any other technology. In addition to automotive lighting, OLEDWorks also offers OLED lighting for specialty applications and markets. Shown here is an example, working with the Strong Museum of Play. We worked with them to create 144 OLED butterflies that welcome visitors in the new atrium at the museum. The installation includes digital signage explaining the benefits of OLED lighting, and donors actually were able to name specific butterflies in order to raise funds for the Strong Museum of Play. Nearly 1 million people per year will experience this canopy of OLED butterfly lights. So again, using the technology for something very different than automotive is just another example of the broad aspects of applications that are possible. Also mentioned by other people, we're looking at things like medical applications, for example, as another area of interest. So that was just a short introduction to the latest developments in OLED lighting and how we're revolutionizing lighting for the automotive market and other specialty markets. For more information, you can check out the OLEDWorks website or the Atala microsite shown here. And thank you again for your attention.
I think many people will reach out, Michael. Thank you so much. I was curious, because with the right, if you're looking at the current developments, when we speak about the developments of OLEDs, I remember a couple years ago you were saying about that you're developing now 2 stacks above one another, 3 stacks about one another to increase the brightness. So what is maybe the driver behind your current developments? Is it still brightness? Is it reliability, unusual shapes, form factors, or?
So the short answer is all of the above, right? Every car. I mean, what we're making here really are custom light sources designed specifically for individual car models. We're not making millions of the same product. We're making tens of thousands of a single product, and then expanding that to another product and another product after that. So it depends on the car. It depends upon the OEM. Tail function only requires something like 2,000 to 4,000 nits brightness. We can achieve that very easily with our 2-stack OLED. But daytime communication requires more like probably 15,000 candela per meter squared in order to have a good visibility in the daytime. And so for that, we're moving towards a 4-stack OLED to get that kind of brightness and still maintain the lifetime required for the 15-year use of the car. So brightness for sure, for certain applications. Reliability is a requirement of every product. And if we hadn't achieved that kind of reliability that I've already shown, we wouldn't be in any cars. So reliability is table stakes. You can't even get into the car without that. More stacks beyond 4 if we need things like stop function, or if you start talking about things like daytime running lights or augmented type systems for daytime running lights, we're going to need even more brightness, which will require more stacks, again, to maintain lifetime. So different colors, different numbers of stacks, sizes, shapes, bendable, rigid. All of this is important to broaden the scope of applications that we can apply OLED technology to.
Mm-hmm. Do you think now it's limited to, let's say, amount of stacks or also to the chemistry of the organic materials?
Oh, of course, chemistry is also important. We work, we don't make our own OLED materials. We work with the leading companies from all over the world, Asia, Europe, US, everywhere. What our specialty is to bring together materials from multiple suppliers and put them together in a way that is unique, that they can't do themselves because they can't get materials from their competitors. And so, yes, the chemistry, the performance of the OLED materials themselves is critical. We're still, obviously interested in really stable phosphorescent blue emitters. It's been that's kind of the dream of all OLED display manufacturers, is to be able to move away from fluorescent blues to phosphorescent blues when the lifetime is good enough. And we're obviously also in that group that would love to have even more efficient blue emitters, but red emitters and green emitters, all of them are important.
Mm-hmm. Speaking about lighting, about the really automotive lighting solution, there's a question from the chat from OptiWave, Ahmad IT. Ahmad, could you please unmute yourself and ask a question?
Yes, thanks, Olga. Yeah, my question is actually about modulating these LEDs, because I'm thinking about visible light communication. I mean, is it possible to do that as well with these OLEDs?
I mean, OLEDs are directly converting electrons to photons, and the speed at which that happens is extremely fast. Much faster than your LED TV is able to turn pixels on and off. So Modulating the light, for other purposes, I think would be very viable, but that's not what we spend our time on. So I leave the final answer to you, and if we want to talk about it, more, we can do that offline.
Perfect. Thanks.
Another question from Prashant. Prashant, what's on your mind?
No, but Michael already answered the question when you
No,
talked
but
about
no,
what are
you had another question about the colors.
yeah, but it kind of when you asked the question about what are the challenges, he already talked about the next step is to bring more colors and more reliable and make sure that they're reliable. So I think I got my answer. But that's my question was to see because we at least maybe the background for the question was we were approached by a couple of automotive tier ones to really make thin rear lights with additional colors based on ELQDs, right? So, but these are innovation projects, very early stage, and we don't have the reliabilities that you showed. So.
I mean, I mentioned white as an example, but cyan is an automotive color these days because it's being used for autonomous vehicles to indicate that the car is not being driven by a human being. And so we are working with phosphorescent cyan emitters, for example. So when you mentioned cyan and 480 nanometers and stuff, there's definitely interest on the OLED side to also create OLEDs of that kind of color range.
We have one more question from the Vaidhav. Vaidhav, you already had a question. Please unmute yourself and go ahead.
Yeah, actually, I have one question that does it require the specific driver ICs for the OLED? And please.
So OLEDs, so LEDs are typically anode common drivers. OLEDs are typically cathode common drivers. So there are drivers available today for OLEDs for general lighting applications or for automotive applications, but the number of drivers out there today compared to LED drivers is still fairly small. As a new technology and growing, but there are companies like ST Technologies that make OLED specific drivers, automotive qualified.
Okay, thank you so much.
And we have again another question from the auditorium from someone called Jose Pozo, Optica. Jose, please unmute yourself and ask your question.
No, I don't have any questions. I just would like to ask Lucas from Noctiluca if there is something he could do to help Michael from OLED Works about his need for more efficient blue OLEDs.
Yeah, hello, Jose. Hello, Michael. I think we are already in touch, so the things are ongoing.
My job is done.
Like I said, we are open to using the best materials from anybody who makes them.
So Lucas, now that we have you, I think you brought a slide to share everyone what Noctiluca can do.
Yeah, but I think I need to queue a bit more because there's one more speaker in front of me.
Back to you, Olga.
Is that right, Olga?
Yes, it is true.
Okay.
And there's actually a speaker who also has a question. Benjamin, that you also had an interesting question, which I believe will be a great introduction for your own presentation.
Thank you very much. Indeed. Thank you, Olga. My question was about the same. Is it possible to modulate the LED at what speed in order to enable optical wireless communication? Optical wireless communication can be enabled by lighting. You need a minimum of intensity also, and the divergence of the beam, of the lighting beam, is very important. So I'm just wondering if you have some, kind of limitation of OLEDs within the use cases of optical wireless communication, or you can just tell us what is your view on that.
Yeah, I mean, so I'm not an expert in that area at all, but the benefit of OLEDs is it's an area light source. The problem with OLEDs is it's an area light source if you're trying to actually
Yes,
to actually direct the light. right? So OLEDs are great for broad viewing angle because they're Lambertian emitters. So for the back of the car where you want not only the car behind you to see the image, but the pedestrian on the street or the car 2 lanes over, it's a great light source. It's never going to be a headlight because we can't focus the beam of the OLED light to create the beams of light that you want from a headlight. So if for optical, type of communication, you need a focused light source, probably OLED is not the choice for you.
Thank you very much.
Well, Benjamin, then it's the
Okay.
attention of everyone is yours, because you know how you can modulate the lights for communication.
Yes, this is a kind of our job. Thank you very much. Happy New Year for everybody. I will try to explain quickly what is OLEDCom, optical LED communication, not OLED, but LEDs, and how we use light to send and receive information in a very specific environment, high speed, interference-free, and highly secured environment. First of all, we are a French company. We are based close to Paris, close to Versailles, to be precise. And we are really an expert of this technology since many years, more than 10 years. Over the year, we built a strong portfolio of patents. We have 40 people. And we're the first one, very proud of it, to send Li-Fi in space in a satellite of the company OneWeb. It was in May 23. And I must say I'm very proud that the product is still working now, at 1,200 kilometers altitude. We call it the high-low Earth orbit, and it works quite well for intra-cable replacement solutions. We work with many companies around the world, a lot in space. We have developed a lot of applications in space, a lot of application in sensitive environments like defense, but not only. Railways, I will come back to it. And we both use now both Li-Fi, but also we start for certain applications, we start to use lasers also, which is a known technology. There's nothing new, but we use it at a certain speed, which is quite unique. What we are very proud of is that we were the first, together with our colleagues of Pure Li-Fi, to miniaturize the technology. So you see here, it's a €1 cent. So it's a very small coin. And this is a module, we call it an optical front end that is composed of a small VCSEL, a small vertical cavity surface emitting lighting, and 2 small photodiodes and a chip that we have designed, which is called an analog front end. So this is a module which is able to send and receive information at 1 gigabit per second over a beam of 25 degrees at 10 meters. And this is the basic block of the technology of OLEDCom, from which we derive a lot of application using, optics but all our products are based on this small module. We are also we will equip soon the line of the Metro of Paris. The line number 18 is a new line that is going to be launched next year. That is going from Orly Airport to Versailles, so the whole southwest of Paris. And we have specific application we want to share with you today. In space, and I will not come back to it too much, we just announced that a partnership with the French Space Agency, le CNES, Centre National d'Études Spatiales, to launch a product called Lucy. In French, it is Liaison Ultra Compact Intersatellite. So it is an optical intersatellite link that is able to send and receive information at a distance of 7,800 kilometers, intra and interplan communication. So basically, in the same for satellites who are in the same orbital plan, but also for satellites which are, let's say, not in the same orbital plan, because the relative velocities are completely different. And what we are very proud of, if we have designed some specific features in it that makes it the most compact product in the world. So it's a product which is very, very small. The mass of the product is ultra lightweight, at less than 7 kilos, the optical head unit. And this gives, let's say, quite some interesting feature to our product. And we have already plans to start developing it in Europe, but also in the US. The railway application, so this is not laser, this is Li-Fi. We have deployed two types of application for the Li-Fi. The first one, you don't see it maybe very detailed here, but on the low part of the metro, we have, and this is the zoom, we have a Li-Fi transceiver, which is able to download information when the metro is stopped during the 20 seconds in the station. It is enabling a 2.6 gigabit per second download and upload information in the train. Because, today we have so many cameras, high definition cameras in automatic metro, in the front, in the rear, in the back, inside, on the side. So you have 30 high definition cameras. It is recording an absolute huge amount of data. We talk about terabytes in between two stations. And the big issue is how to store it. So basically, we have developed this solution to download the information with the Li-Fi technology. It's interference-free, so it's very reliable, to the key. We have another transceiver which is in front of it when the train is stopped. Another basic application also is simply crossing the railways wirelessly in an environment that is very, very sensitive to electromagnetic interference. Very often high voltage lines, the Wi-Fi doesn't work, so the alternative is to build trenches below the railways, which cost an absolute fortune, and we are able to just do it with in a highly secure way and without any interference. So this is two applications in the railways. Another one is simply in sensitive environments where it's not authorized to use RF. We are able to provide those type of solutions. So here is a point to multi-point solution. On the top of the tent here, or the shelter, you have what we call an access point, a Li-Fi access point, which is able to be connected to up to 32 users. Each laptop is equipped with a small dongle, we call it, with a beam, which is a 125 degrees beam. So it has both civilian and also sensitive applications, like security applications. The big advantage here is simply the installation time. So you can set up a secure mobile command center extremely fast, in 10 minutes for the network, instead of huge amount of cables, because in those environments, because of jamming, because of lack of hacking potential, very often the radio frequencies are not working. So what we had to develop at OLEDcom is not only the hardware based on the module I just mentioned earlier, but also all the software layers to ensure the network security. And we achieved a certification, a secret certification in France and in Germany, a German BSI, and also in the US. We are, let's say, close to finalize our certification with the US authorities, with the NSA. Voilà. So this is just examples of type of use case we are developing at this moment. We have many others, and I would be happy to listen to your questions, to answer to whatever question you would like to have. Thank you very much for your attention.
Benjamin, thank you very much. Merci beaucoup. You're doing a fantastic job. We love Li-Fi technologies and the fact that you are really deploying them, By the way, we are waiting for our invitation for the opening of the line 18 of the metro in Paris. Is there
With
any
pleasure. With pleasure.
challenges that you have for the partners in the room when it comes to luminaire manufacturers or OLED suppliers, or is there any request that you have for the people in the room to help you with the next deployment?
I think that today the clear limitations when you use LEDs on the Wi-Fi is the cutoff frequency. So and you know, our clients now they would not change technology from Wi-Fi to Wi-Fi or to new technologies without making sure that the potential is quite huge. So they are all asking, even if they don't need, they will ask 10 gigabit per second minimum. Otherwise, they will not make the move. So the current LED technology is quite a limiting factor because, you know, maybe some of the best LEDs would have a 30 megahertz cutoff frequency. Micro LED could be interesting, by the way. It's an alternative which has a higher cutoff frequency. So basically, you know, all kind of solutions, even VCSELs, high power VCSELs that could have also a high cutoff frequency. Everything about that is very interesting for us, and we'd be happy to. We are using infrared, so invisible light, from 850 nanometer, 940 nanometer, 1050 nanometer, but also now more and more the 550 nanometer, the telecom, which is mostly used in telecom.
Benjamin, this is really fantastic. We are looking for new emitters for OLED.com. And Benjamin, you said in your slides clearly that you're also working not only in metros, or you're also working in the defense sector. So I guess that you also are looking for geographically constrained supply chains for some of your customers, the European manufacturer. Can you tell us a bit about this?
Yes, absolutely. We need to have very often our customers will ask for sovereign technology. So in Europe, our European customer will ask for European sources. Our US customer will ask for US sources, both in defense but also in space. It will be very difficult to have in a governmental satellite, for instance, technology which is not having a source which is, let's say, secure for government point of view. So yes, European. I mean, they also very often accept Japan. They would accept Singapore, but you know, it is a sensitive issue. I agree.
Definitely, and taking into account especially the technologies that you want that traditionally some of them are not made in Europe, but we are lucky because we have fantastic organic material made in Europe. Lukasz, thank you very much. Now it's your turn, coming all the way from Poland. The floor and the attention of everyone goes to Noctiluca.
Thank you very much. I think we ran out of the time, but Olga, I strictly follow your rules. And just 2 slides has prepared. So hopefully you will survive with me a bit longer. Please tell me if you can see my screen.
Crystal clear.
Crystal clear. Thank you. So to begin, I would like to first of all thank you for the invitation and opportunity to be a part of this fantastic seminar. It's a great pleasure to be among such distinguished speakers we have here today. As we begin a new year, let me also, on the behalf of the Noctiluca team, wish you all a successful, inspiring, and prosperous 2026. My name is Łukasz Sytniewski, and I'm a product manager at Noctiluca, a Polish-based company that creates materials for the products of the future. As we could see today, we have many of the products which I believe will change the future soon, and I hope that Noctiluca will be part. However, today I'm excited to share how our product, NCAL4, is enabled to unlock and significantly extend the lifetime of OLED devices. And what I think I stopped sharing, sorry for that, pressed the wrong button.
No, you're sharing. Maybe wrong screen.
Very
Try to
okay.
progress.
Maybe, yeah. Okay, let me. I just can't see my presentation right now. I don't know why.
I only see the first slide. Maybe try
Yeah.
once again.
Okay. Let me stop and start again. I don't know what happened.
Sometimes happens.
And can you see my slide again?
Yes.
Yes. And
Yes. Progresses.
we are on slide 2, so the last one. So our product was developed as a solution for the real need. Optica is actively participating in so-called race for blue. Michael, you already mentioned today that problem. As we all know, blue devices still suffer from the efficiency, particularly in the lifetime. That in comparison to, of course, to the red and green devices. Since Optica early years, we have been intensively working on what many consider of the as a holy grail of the industry. So the new blue TADF emitter. However, as Michael already said as well, the problem of industry is here and now. For this reason, our approach has evolved over time. While continuing emitters development, we also focused on the introducing high-performance material that can be applied to the existing OLEDs architectures. That is why, and that is why NCL4 product was created. Our product is a proposal for electron injection layer, a very thin, however, extremely important layer in the entire OLED stack that enables electron flow from the metal cathode towards the organic matrix. Unlike other available solutions on the market, our product is not metal or lithium based. Initially, we evaluated NCL4 in a blue bottom emitting diodes together with one of our research partners. The test results encourage us to move towards more demanding top emitting devices. Today, NCL4 is used in the industry and is being evaluated with more than 15 partners across display and lighting, as well as in OPVs and perovskite-based applications. We've started also test in red and green OLEDs. Well, one can ask what makes NCL4 so special. We observe benefits of using of our product on the 2 levels. One is the material level itself, and the second is its performance in the device. On the material level, NCL4 can be considered as a direct exchange with a well-known lithium-based EIL material called LIQ. Both materials exhibit very similar HOMO and LUMO energy level, that allowing direct exchange without necessity of changing the entire OLED architecture. NCL4 is supplied as a high purity sublimed grade, so essential and crucial for PVD fabrication. More than that, our product shows good solubility in selected polar solvents, which we believe it might be an added value for printed electronic processes. On the device level, the most important benefit is a significant improvement of operational lifetime compared to LIQ-based devices. This was successfully proven for top and bottom emitting devices by both research and industrial partners. For the importance of the color purity, we haven't observed any influence on the electroluminescence spectrum in the device in which NCL4 was used. Additionally, the use of NCL4 can lead in some cases to reduce driving voltage and therefore lower the power consumption, so important for the battery powered devices. And finally, NCL4 It's not only the AL material, but can be also used as a dopant to electron transport layer, and in some cases use in those two layers at the same time. To illustrate the lifetime enhancement potential of MCL4, please refer to the plot presented on this slide. The data correspond to the blue bottom emitting test diode with an aluminum cathode. As a reference, LIQ was used as an electron injection material, resulting in the lifetime LT90 of around 8 hours. That's a black line in the plot. By simply replacing LIQ with NCl4 in the electron injection layer only, the device lifetime increased by the factor of around 5, green and blue line on the plot. When we introduce NCl4 as a dopant to the electron transport layer while keeping also NCl4 in the electron injection layer, even greater improvement was observed. Devices 3 and 4 achieve approximately 15-fold lifetime enhancement in comparison to LIQ-based reference device. With these results and its strong potential for OLEDs lifetime improvement, we are fully confident that NCl4 represents a powerful and practical solution in today's race for blue. If you would like to learn more about Noctiluca, our portfolio and services, please scan the QR code for the additional information. I will be happy to assist with more details if needed. Thank you for your time. I hope it was quite short.
It was very short and very efficient. Dziękuję bardzo, Lucas. You measure your devices, or at least you characterize your devices at 1000 nits. But we saw Michael today in a fantastic presentation from OLEDWorks talking about 2000 nits. Do we expect a big change? Are you working on characterizing at 2000?
Well, it's the 100 nits is, let's say, academic approach. But industry normally tested the devices under constant current. Yes, we do have some results, not some results for the constant current, and for sure, far brighter luminescence.
Michael.
Yeah, I was just going to say, mostly what from my perspective, seeing a comparison at a constant brightness for all the different devices is fine. Our interest would then be, if we needed to get higher brightness and maintain lifetime, is to do the stacking technique, right? So if we need 2000 nits and still have the same lifetime as we get at 1000 nits, then we would go to 2 stacks instead of 1 stack that is shown here. So
I would like to thank all of you for a great event. What I'm going to do now is I'm going to close the YouTube link. But for those of you in the Zoom channel who would like to stay for an after event beer, you can stay. Just don't close your connection. For those of you who have to leave, just leave. But first of all, thank you very much, everyone watching in Zoom and YouTube, for a fantastic, really fantastic meeting.
This is Optica. This is lighting redefined.
All right, I would like to now ask my IT department, who has done a fantastic job, the meeting went really smoothly, to close the YouTube link. We say goodbye, and now this becomes a private room. Nobody can hear it. Whatever happens at the Zoom room stays at the Zoom room. Olga, great job. Fantastic meeting. How did you think it went?
Oh, spectacular. Thank you very much for everyone. I really loved the content because it was really a valuable and technical and a business discussion. I think it will be one of our hits in all of our of the corporate engagement industry channel, YouTube channel. Thank you so much. Yeah, that was really interesting. And I wanted to pick up on the conversation that Michael had with Benjamin before on the the Signify facility that you bought and that you're now actively using, I guess, for producing Atala.
Yeah. So it's so it was a former Philips facility. It's in Aachen on the former Philips campus that's in Aachen. We've been there now for going on 11 years and started off again with 35 people and no business at all. Really, no sales, and we've now grown that to over 200 people. And as I've mentioned, we're in multiple cars that are on the road today. I've sold hundreds of thousands of OLED lighting panels for those applications, we're thrilled to have that former Philips team as part of OLEDWorks.
Michael, to be honest, I was a little bit surprised to hear that you say that you developed the new lighting solution for every new model. It sounds expensive.
So what we're doing is, mostly what we're doing is we're changing the size and shape of the panel and the segmentation. So that it's not a full development of a new OLED stack or things like that typically. And so that's not expensive really in terms of the NRE for new masks for a new layout is not tremendously expensive compared to other